आप लोगों की अटेंडेंस मतलब ये जूम में 5 मिनट पहले से आपको तैयार रहना बच्चों, ठीक है। चैट फैकल्टी से बात कर सकते हैं आप लोग। मैम चैट फैकल्टी नाम कर दीजिए, इसका नाम बदल नहीं रहा, वो होस्ट बनाओ। लाइव हो गया। शुरू करते हैं बच्चों। वर्टिकल सर्कुलर मोशन बहुत ही मजेदार टॉपिक है और बेसिक्स को ध्यान रखना है। एक कंजर्वेशन ऑफ टोटल मैकेनिकल एनर्जी पे बेस्ड है। ओके, हेडिंग डालो वर्टिकल सर्कुलर मोशन। नोट्स जैसे मैं बना रहा हूं वैसे ही बनाना, कॉपी सेम टू सेम, बहुत अच्छे नोट्स बनाना, ठीक है। दिस टॉपिक is based on conservation of total mechanical energy. Okay, the most important point, basics required. First basics required, net force acting towards center. Net force acting towards center provide centripetal force. Net force to present towards center provides centripetal force. Second point, if sufficient centripetal force is not present, particle leave circle. Formula of centripetal force is mv square by r or m omega square r, because omega is equal to v perpendicular upon r perpendicular. याद है तुम लोग को बच्चों?
Yes, sir.
ओमेगा और v याद है ध्रुव? Okay, so this you can write m 2 pi by t whole square r. This you can write m 4 pi square by t square r, m 4 pi square frequency square into r, because 1 upon time period is frequency, and always remember omega is also equal to 2 pi by capital T. Okay, now here the meaning of total mechanical energy means total mechanical energy represent sum of potential energy plus kinetic energy. Okay, and in absence of in absence of non-conservative force. Non-conservative force क्या होते हैं बच्चों? Like friction, air friction, हवा के कारण जो फ्रिक्शन लग रहा है वो, या मैग्नेटिक फोर्स भी नॉन कंजर्वेटिव फोर्स है क्योंकि वो वेलोसिटी और पाथ पे डिपेंड करता है. इन एब्सेंस ऑफ नॉन कंजर्वेटिव फोर्स, टोटल मैकेनिकल एनर्जी of system remains constant या conserved. Copy. Right, point number 5. We can assume reference point anywhere, and at reference point and at reference point we assume potential energy is 0. Okay, copy. Done. Take your time.
Sir, where we have to send the message?
Chat faculty.
Sir, it is not showing.
Wait a minute. करता हूं मैं अभी, है ना? ये लिख गया, पहले बताओ।
Yes, sir.
ओके, अब हम स्टार्ट करते हैं पेंडुलम से। राइट, पेंडुलम। बच्चों मान लेते हैं ये एक पेंडुलम है जिसे आपने इस h हाइट से छोड़ दिया। ये इसकी रेफरेंस हाइट है, ये इसकी नॉर्मल हाइट है जब ये वर्टिकल हो जाएगा। ठीक है, ये पॉइंट ए हो गया, ये इधर से इसी एंगल तक जाएगा। मान लेते हैं एयर एब्सेंट है, तो एयर नहीं तो इसको स्लो डाउन कर देगा। मान लेते हैं ये कांच के डिब्बे के अंदर है और उस डिब्बे के अंदर एयर नहीं है। ये एंगल थीटा, एंड दिस इज पॉइंट बी, and I'm assuming this as the reference point. This is the reference point. The reference point मतलब ग्राउंड। ठीक है, यहाँ पे पोटेंशियल एनर्जी 0 है। गूगल पागल हो गया। ओके, रेफरेंस पॉइंट पे पोटेंशियल एनर्जी क्या हो जाएगी बच्चों? 0। इट्स अज्यूम दिस पॉइंट इज सी। अब एक बात अज्यूम कर लो। लेट्स अज्यूम एट पॉइंट ए पार्टिकल इज एट रेस्ट। मान लो पॉइंट ए पे पार्टिकल रेस्ट पर है, आपने उसको छोड़ दिया वहां से, और स्ट्रिंग की लेंथ L है। ओके, और वी विल ट्राई टू कैलकुलेट काइनेटिक एनर्जी एट पॉइंट C and tension in a string at points A, B and C। चलो ये कैलकुलेट करते हैं और पहली बार कंजर्वेशन ऑफ टोटल मैकेनिकल एनर्जी लगाएंगे। ठीक है देवराज, तैयार है?
Yes, sir.
तो बताओ पॉइंट ए पे पोटेंशियल एनर्जी 0 है या कुछ है?
कुछ है।
कुछ है, पोटेंशियल एनर्जी 0 नहीं है। तो इसको हम ऊंचाई को h मान लें।
Yes.
ओके, क्या आप में से कोई मुझे h कैलकुलेट करने में मदद कर सकता है? पूजा मैम को भेजना मम्मी।
यस सर।
उनको बोलना बच्चे मैसेज नहीं भेज पा रहे, सेटिंग बदल दे। h is now look at this triangle बच्चों, ये कितना आएगा? ये हाइट कितनी आएगी आप बताओ, ये हाइट, ये कितना आएगा इस ट्रायंगल में?
L minus L sin theta.
ये तो सीधा L cos थीटा आ जाएगा ना,
Cos
L
theta.
cos theta.
है ना? और पूरी लेंथ कितनी है धागे की?
L
L है, तो कैन यू टेल मी व्हाट इज H?
L minus L cos theta.
Correct. So H is L minus L cos theta. So now let's assume at point C speed is, मान लेते हैं उसकी जो स्पीड है वो v है, at point C speed v है, और at point A it is at rest. ओके, तो क्या मैं ये मैम बच्चे मैसेज नहीं भेज पा रहे चैट फैकल्टी को, अलाउड नहीं है। अब क्या ऐसा करें कि पॉइंट सी पे वेलोसिटी आ जाए, इसका मास m मान लो। What we can do so that we can find velocity at point C? Say total energy at A must be equal to total energy at C. Okay, understood? So at A, what you have? At A, you have some potential energy, and the kinetic energy at A is 0. Am I right? Is equal to
Yes, sir.
total
Sir,
potential energy at C plus kinetic energy at C. So at A, potential energy is mgh, and h is L minus L cos theta, and kinetic energy is 0. वही तो है, OSHA भी तो बनाया था. Okay, and kinetic energy is 0 at point A. Am I right?
Yes, sir.
Now write what is kinetic energy at point C and potential energy at point C. Yeah. इसमें दिख ही नहीं रहा. Okay, so what is the potential energy at C? C को हमने क्या माना है?
0.
0.
Yes, because we assumed C as reference point, so we can assume C is ground. So potential energy at C is 0. Very good. Now you can send message to chat faculty. We have changed this setting. And kinetic energy at point C is this. Okay. So mg, let's take L common, 1 minus cos theta is equal to 1 by 2 mv square. M got cancelled. So what is velocity? What is velocity, bachcho? 2gl 1 minus cos theta under root. Any doubt? At point C. At point C. Can you help me in calculating tension at point C? Is this equal to mg? Tension at point C is equal to mg or more than mg or less than mg? Because mg is acting downward. Mg is acting downward. And tension is acting towards, tension is acting away from the particle, means like this. And this time this point is center, O. O is center of the circle. You can assume this circular motion. You can assume this part of the motion as circular motion. Am I right? So can you please tell me what is tension? It is more than mg or less than mg? Arpit is saying less than.
More than.
Dhruv is saying more than mg.
So more than mg.
Shruti is saying more than mg. Hers, what is your opinion? Devraj is saying more than mg. Shreya is saying more than mg. Sinchana, what is your opinion? Adi is saying more than mg. What is your opinion, Vidhi? Hers is saying more than mg. Lot of students are saying the tension is more than mg. Sinchana is also saying tension is more than mg. So I'll tell you a very basic. Say with me, net force acting towards center of the circle will provide centripetal force. Say with me.
Net force acting
Force.
on the center of circle
Towards center provides centripetal force.
Net force acting towards circle will provide centripetal force. Let's copy this diagram. We have reduced the size of the diagram. Now see what I am going to write. Net force acting towards center will provide centripetal force. Am I right? So what is net force towards center? Where is center of the circle? I believe this is center of the circle. Am I right, Devraj?
Yes.
Yes, sir.
Center की spelling. We can assume this as center of circle. So net force towards center of the circle is T minus mg. Am I right?
Yes, sir.
And this will provide centripetal force mv square by r. Above, you can transfer mg other side. So you get mv square by r plus mg. So the value of T is more than mg. You all are right. A lot of students gave correct answer. The value of tension is actually mv square by r plus mg at point C. Tension at C. So tension at C is more than mg. समझ गए बच्चों? We calculated velocity at point C, okay, and we calculated tension at point C. Can you help me in calculating tension at point A? Anyone, please answer. What will be tension at point A? To calculate tension at point A, we will again make diagram. See this. Smooth this. I don't need. You don't need all this. One thing is for sure, bacho. At point A, the particle is at rest. Am I right?
G cos theta plus mv square by r.
Very good. mg is acting in this direction. If you take components of mg, you will get this. You can make two type of component of mg, one like this and one like this. Okay, and if this is theta, because this is theta, what is this component, bacho? This component mg,
G cos theta.
and this component mg,
Sin theta.
and this is t. So t, tension at point A must be equal to mg cos theta. So tension at point A is less than mg because cos theta will be less than 1. Understood, bacho?
Yes.
Okay.
Yes, sir.
Now what we have learned how to use two equations. First equation is total mechanical energy conservation equation, and next equation we have learned net force acting towards center will provide centripetal force. On the basis of this much knowledge, can you answer me this? There is a car. Imagine a car. It is moving with velocity v. This is point A. At this point, normal reaction is N and A. And there's no doubt mg is mass, weight is mg, right? I have one question. Suppose this point is B, and suppose this point is C. Can you tell me value of normal reaction at different points? Consider velocity of the car is same. Assume velocity of car is same. पेट में गुदगुदी लगती है कि नहीं ऐसे रोड में? याद करो विधि, जब ऐसे रोड में कार में बैठते हैं देवराज तो पेट में गुदगुदी लगती है कि नहीं लगती? लगती है ना? वो क्यों लगती है? Here, always represent mg. Always represent all the forces. Mg is acting downward. Can you tell me value of normal reaction at 3 different point A, B, and C? ये चालू नहीं हुआ अभी. Hello, am I audible? Anyone can calculate normal reaction.
तो फर्स्ट में mg होगा, सेकंड में mv स्क्वायर बाय r माइनस mg.
Wait,
और-
wait. This is correct. First is correct. श्रुति second में क्या है?
mv स्क्वायर बाय r माइनस mg.
mv square by r minus mg. How you got this?
Sir, net force acting towards center will give centripetal force. So normal plus mv square by r is equals to mg. So by transferring mg.
Correct. See this. But now everyone concentrate here. Everyone look at the screen. This is center of this circle, right? Suppose this is a circle and center of the circle is O. Can we assume? थोड़ा और
Yes.
नीचे बना.
Yes.
So what is net force towards center? What is net force towards center?
mg.
Arpit, is it mg or mg minus nb?
mg.
mg or mg minus nb?
mg minus n.
And this will give you centripetal force. So transfer nb other side, you will get mg minus mv square by r is equal to nb. So you got normal reaction at point B. Understood? Everyone could understand this? Click on yes.
Yes.
Click on yes, everyone. Arpit? Okay. Adis? Okay. Okay.
Excuse me, sir.
Huh?
Sir, can you please show the answer of Shruti?
ये है ना आंसर श्रुति. अरे उल्टा है, क्या कर रही श्रुति?
सर इसने क्या गलती करी सर इसमें?
इसने mg और nb को जोड़ दिया, गलत है.
सर इसने फ्रेम मिक्सिंग कर दी सर. सर
अब तो-
बैठी थी सर ये किसी और फ्रेम में और उसने लगा दी इक्वेशन किसी और फ्रेम की.
हाँ भाई, मेरे को तो ये समझ में आता है कि नेट फोर्स टुवर्ड सेंटर विल प्रोवाइड सेंट्रिपिटल फोर्स एंड नेट फोर्स टुवर्ड सेंटर इज mg minus nb. ओके, एंड दिस मस्ट बी इक्वल टू सेंट्रिपिटल फोर्स. अब आप nb को उधर ले जाओ तो mv स्क्वायर बाय r इधर आ जाएगा, तो ये नॉर्मल रिएक्शन एट b आ गया. तो श्रुति ने प्लस माइनस की गलती कर दिया. ओके, चलो let's look at the same car when it is at point C. Where is center of the circle? Right? O. So again, what is net force towards center? Net force towards center. Jaldi, come on, tell me. What is net force towards center at this point?
nc minus mg.
NC minus mg. How you can say mg minus nc? NC minus mg. Which force must be bigger? Do you need force towards center or not? This car is performing circular motion or not? Say yes or no.
Yes, sir.
Means this car needs a centripetal force. So normal reaction will have to be greater than mg. It cannot be smaller than mg. Okay, so nc is greater than mg and normal reaction at point C will give centripetal force. Normal reaction, net force towards center will give net centripetal force. So it is nc minus mg because mg is going away from the center. Am I right? mg तो center से दूर जा रहा है ना?
Yes, sir.
Yes,
Okay.
sir.
Is this correct net force towards center, Arpit? Arpit,
Yes,
is
sir.
this okay? This must be equal to centripetal force. So normal reaction at NC is more than mg. This question came in IIT Advanced. Okay, so maximum normal reaction is at C and then A and then minimum at B. So maximum normal reaction at C, then normal reaction at A and the minimum normal reaction at B. इसलिए हमारे पेट में गुदगुदी लगती है because normal reaction will change. तो हमारे पेट का फ्लूइड ऊपर नीचे होता है. Understood बच्चों?
Yes, sir.
Yes.
Okay. आगे बढ़े. Copied this
Yes, sir.
question. The question is compare values of normal reaction at 3 different points. The question is to compare normal reaction at 3 different points. Please copy. Okay. Done?
Yes.
आगे बढ़े. Okay. In case of any doubt, आप मुझे वहीं रोक दीजिएगा, ठीक है? क्योंकि ये बहुत इंपॉर्टेंट टॉपिक है और इसमें बहुत ही सारे क्वेश्चंस आने वाले हैं. बहुत ही सारे
Sir,
मतलब बहुत.
पीछे कर.
ये लो. और
No, sir.
डन. डन. ओके.
Yes, sir.
अब मैं एक थोड़ा सा कैलकुलेशन वाला क्वेश्चन दे दूं. हाँ. फाइंड
Yes.
speed and tension in string when string makes 30° with the vertical. बच्चों ये hinge point है A, O point, and this is a particle of mass m. It is released from rest. Released from rest. Length of the string is 1 meter. Mass is 1 kg. Your task is to find tension and speed of this particle when string make 30° angle with a vertical. Suppose its speed is v and they want tension also. You have 1 minute. You all have 1 minute to answer my question. मैम एक बार साउंड चेक भी कर लेना. टाइम सेट करना पड़ेगा. किसी कंप्यूटर वाले को बुला के इसकी घड़ी सही करवानी पड़ेगी, सेल बदलवाना पड़ेगा, तब हमेशा इसमें नेट एक बार में चलेगा. इधर ही क्लिक करके देखो. बहुत साल लग जाएंगे. आता तो कैसे होगा। चलो बच्चों, अब मैं करूं। Length of string is 1 meter. Assume this as the reference position. At reference position, potential energy is 0. Understood?
Yes.
This length is 1 meter. And this height is 1 meter. This height will be 1 meter. Am I right, bacho?
Yes, sir.
So what is height of this? What is this height? Say L minus L cos theta. Do you remember the last problem?
Yes, sir.
This is L cos 30. The complete is L. Complete is L. So this height must be L minus L cos theta. Understood?
Yes, sir.
This is suppose point 1 and let's give it name point number 2. So okay, can I write total energy at point 1 must be equal to total energy at point 2. Okay, Arpit? Okay, Adis? Devraj?
Yes, sir.
Yes,
Hers?
sir.
Okay, Hers? Shreya, Shruti? Sinchana?
Yes, sir.
Okay. Okay, Paras, okay. Now what I should do? Come on, tell me. What is total energy at point 1? Kinetic energy is 0. Am I right?
Yes.
And
Yes,
potential energy
Yes,
is
sir.
mgh, where h is equal to 1 meter. So shall I write 1 meter directly? M is
Yes.
1 kg, G is 10. M is 1 kg, G is 10, and h is also 1. And total energy at point 2. So potential energy is mgh. So M is 1, G is 10, and height is
L
1
minus
minus
Minus L cos.
L minus L cos 30 matlab 1 minus cos 30. Am I right?
Yes, sir.
Plus kinetic energy 1 by 2 mv square. So 1 by 2 m is 1 and v square. Could you understand this?
Yes, sir.
Yes, sir.
10 1 minus root 3 by 2 plus 1 by 2 v square. चलो अभी ट्रांसफर दिस थिंग अदर साइड. श्रुति ये जल्दी से कैलकुलेट कर दे. चिन्मय सही सही कैलकुलेट करना. माइनस प्लस 5 root 3 is equal to v square by 2. Could you understand what I did? अर्पित समझ में आया?
Yes,
मैंने
sir.
अंदर मैं उसको उस
Yes,
तरफ
sir.
ले गया और मैंने सॉल्व कर दिया थोड़ा सा, है ना? तो ये 10 root 3 under root speed. Could you understand that?
Yes, sir.
So this is approximately 17.32 meter per second. कैलकुलेटर से बताओ कितना हो रहा है?
4.16.
4.16 meter per second. But question is not over. They want one more thing. They want tension at point 2. So what is tension at point 2? Can you help me? Represent all the forces. Your step 1 is represent all the forces. mg will be acting here. You can take component of mg. अर्पित एक कंपोनेंट इधर आएगा, है ना?
Yes, sir.
और एक कंपोनेंट इधर आएगा. आदेश इधर ही आएगा ना बच्चे?
Yes,
ऐसा
sir.
है ना? तो ये येलो वाला कंपोनेंट क्या आएगा?
mg sin theta.
MG sin 30.
mg sin 30 and the red one mg cos 30.
mg cos 30.
You should not have any doubt here. This is 30-degree angle. That's why. So this is mg cos 30. So what is net force towards center? That is O. O is center of the circle. What is net force towards center of circle?
P minus MG cos 30.
Correct. Net force towards center of circle. Fast. T minus mg cos 30, and this will provide mv
Center.
square,
Centimeter.
and r is 1,
Fine.
m is 1, g is 10. So 1 into 10 into root 3 by 2 is equal to 1 by 1 into v square. What is v square, bacho? 10 root 3. V square is 10 root 3. Am I right? So t is equal to t minus 5 root 3 is equal to 10 root 3. So tension will be 15 root 3 Newton. Am I right? Tension at point 2. Am I right or not?
Yes, sir.
Yes, sir.
So this is a good question. This is a tough question. Good बहुत सारा calculation किया. In this question, we applied conservation of total mechanical energy as well as we applied net force towards center will provide centripetal force. We are trying to learn these two important concepts here. Remember, Dhruv, calculation mistake से answer गलत होता है. Okay. Now write. मैम वो आपने मेल कर दिया था मुझे सर्कल वाला. Okay. Now let's solve some questions. Can you handle question number 1? Give me a minute. मैंने अभी बहुत थोड़ा सा पढ़ाया है. Can you handle problem number 1? Very good question. Do you need my help? Let me give you a hint.
A.
Almost smooth है अब. Okay. Assume this is a block going with certain velocity v. Okay. छोटा ब्लॉक बनाना चाहिए था, मैंने थोड़ा बड़ा बना दिया, बट चलेगा. Assume this block reached at this point. Why we are assuming this block reached at this point? Read question and underline at highest point of the track. Underline highest point of the track. Imagine तुम खुद, imagine yourself standing on this block and this block is going very fast, very fast. So is this possible or not that block will reach at that point? Probably, if it is moving very fast. Paras, you are right. Paras, you are right. Very good. So suppose block reached at the topmost point. Now where is normal reaction, bacho? Away from O or towards? Normal reaction this side. Understood? And mg also
Downwards.
downward. Understood, everyone? Suppose speed is v dash. Speed is v dash. So what is net force towards center, boys?
N plus mg.
N plus
Net force towards center is n plus mg, and this will provide this will provide what?
Centimeter.
mv square by r.
mv square by r. So normal reaction must be equal to mv square by r minus mg. Understood? The question is, in which case normal reaction is maximum? Okay. So in all four cases are this, the value of radius is different. है ना? Here value of radius is very small. See the small circle. So in option A, radius is small. Am I right? And in option D, it is a big circle, big. So option D, radius is big. Understood?
Yes, sir.
Now imagine
Yes,
if
sir.
you put very small value of radius, you'll get big value of centripetal force. Am I right?
Yes,
Yes.
sir.
अरे
Yes,
नीचे
sir.
वाला नंबर छोटा होगा तो ओवरऑल फ्रैक्शन बड़ा होगा कि नहीं होगा? हर्ष बता
Yes,
तू
sir.
खुद,
Yes, sir.
है ना? तो if the value of mv square by r is big, it means normal reaction is also big.
Big.
Small radius, bigger normal reaction. So normal reaction is maximum in which case?
Radius is minimum.
Case A. Case A has smallest radius. और अगर रेडियस छोटा है तो mv square by r बड़ा हो जाएगा तो नॉर्मल रिएक्शन भी बड़ा हो जाएगा. अंडरस्टूड?
Yes, sir.
Yes, sir.
दिस इज एन IIT JEE
Yes, sir.
कोर्स. आई थिंक तुम लोग को मजा आया ये करके. अंडरस्टूड? आगे बढ़े.
Yes, sir.
कॉपीड.
Yes, sir.
Yes, sir.
बच्चों breaking strength of the string is double the weight of the bob. Means maximum possible tension this string can withstand is 2 mg. Could you understand that?
Yes, sir.
Maximum possible tension in the string is 2 mg. Okay. The bob is released from the rest. When the string is horizontal, the string breaks when it makes an angle theta with the vertical. What is theta? See, we used already diagram. Bacho, in this case, what is tension? In this case, what is value of tension? Let's suppose this is TA. What will be tension? Particle at rest. So net force towards center will provide tension. You don't need any net force towards center because speed is 0. So requirement of centripetal force is 0. So tension is also
0.
0. Particle is not moving at all. So you don't need any force towards center. Am I right? If you don't need any force towards center, it means there is no tension in the string. Am I right, Vidhi? Understood, Vidhi? Okay. Now, as Bob starts moving, it will gain some speed. Agree? Will gain some velocity. So what will happen? The value of tension will start increasing. Am I right? The value
Yes,
of tension will start increasing. And as you can see, mg is here. You can make a component of mg as they did. This component of mg is mg cos theta. Okay. This is mg cos theta. Ignore this. Can you see this mg cos theta?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
And here you will get
mg sin
mg
theta.
sin theta.
mg sin theta. Suppose that angle theta string will break. So string will break only if t is little bit more than 2 mg. Could you understand that? String will break if tension is little bit more than 2 mg. Could you understand that? So what is tension when particle at B? Let's assume at point B, tension in a string just more than 2 mg and string breaks. Okay, understood, bacho?
Yes, sir.
What is net force towards center at this point?
T minus mg cos theta.
T minus mg cos theta, and this will provide so this is one of the equation. What value of T you can write? Can I use 2 mg? Because it is just more than 2 mg. So can I write its approx value 2 mg? Yes or no? Click on yes if I If you allow me to write it 2 mg, click on yes. Okay, thank you, Sinchana. Thank you, Ars. Okay, thank you everyone for responding so fast. You all are very genuine student. I'm very happy. Okay. आदेश में t को 2 mg लिख रहा हूं बच्चे. Minus mg cos theta is equal to mv square by r, but there is a problem. We can get value of cos theta if we know v, value of v. We don't know value of v. You can take m common and cancel. The only problem is you can take g common, 2 minus cos theta into r is equal to v square. So we can get value of cos theta if we know value of v. Can you help me getting value of v? Do you know any method how to calculate value of v? Anyone? Please message me. How to find
The
speed?
total energy.
Very good. By conservation of total mechanical energy, by conservation of total mechanical energy, we can write total energy at A is equal to total energy at B. So what is total energy at A? Kinetic energy is 0, and you can assume this as a reference point. So what is total energy at A?
Yeah.
What is height of point A? R, mgr. Okay, what is total energy at B? At B you have some kinetic energy. And what is height of point B? Come on. What is height of point B? This complete is R.
minus R cos theta.
R minus R cos theta. Could you understand that? Can everyone understand this?
Yes, sir.
The total height is R. And if you subtract R cos theta from R, you will get height of point B. R minus R cos theta. Understood everyone? So here we can write M
Yes, sir.
E and height as R minus R cos theta. I can take R common, 1 minus cos theta. Understood?
Yes.
Okay. Now take M common and cancel. GR यहीं रहने दो, उसको इधर ले जाओ, minus GR. 1 minus cos theta is equal to 1 by 2 V square. Take GR common and transfer to other side. Take GR common and multiply by minus into the bracket, you will get. First multiply minus GR into the bracket, you will get. GR got cancelled, right? V square by 2. So what is V square? V square is 2 GR cos theta. Understood everyone?
Yes, sir.
If we put this
Yes,
value
sir.
of GR cos, if we put this value of V square in equation A, we will get angle theta. Is this difficult? Put it, come on. RG 2 minus cos theta is equal to 2 GR cos theta. GR got cancelled. 2 minus cos theta is equal to 2 cos theta. 2 is equal to 3 cos theta. So theta is equal to cos inverse 2 by 3. Okay, Devraj?
Yes, sir.
Answer is C. Very good question. Please copy. Please copy word by word and solve it 2 times by your own without looking at solution. Standard question, important question. You may get this question in IIT mains or NEET. बहुत chances हैं. Done? Done बच्चों? Okay. चलो अब अभी तो काफी कुछ बाकी है. This is just beginning. Tomorrow I'll teach you critical vertical circular motion. Before that, let us solve one more question. This. What is the speed of the bob? Assume point A as point B as the reference. This is a reference point. At reference point, you can assume energy 0. So potential energy at B is 0. And potential energy at A. What is potential energy at A, Devraj? Devraj, what is potential energy at A? You tell me, Dhruv. What is potential energy at A?
2G.
Huh?
Sir, it's M GL. Sir,
What is height of point A from B?
sir, L.
So potential energy at A is mgl. Understood?
Yes, sir.
पोटेंशियल एनर्जी समझ गया देवराज. अब रेफरेंस पॉइंट से जितनी हाइट पर है वो ऐसे हो जाएगा ना. आर यू देयर देवराज? कैन यू लुक एट माय स्क्रीन बच्चों? ओके ओके.
Yes, sir.
Yes.
Yes.
Okay. At A particle at rest. So what is kinetic energy at A?
0.
0.
Okay, and let's assume kinetic energy at A is 1 by 2 mv square. So let's apply total energy at A is equal to total energy at B. So total energy at A is kinetic energy 0 and potential energy mgl. Total energy at B बच्चों, potential energy 0 1 by 2 mv square. So mm got cancelled, root 2 gl. So speed at B is root 2 gl. Now tension, net force acting towards center will provide centripetal force. So what is net force towards center? T plus mg or T minus mg?
T
T
minus.
minus
T
mg.
minus.
T minus mg will provide centripetal force, that is mv square by L. So what is V square?
2gl.
2gl by L. LL got cancelled. Okay, so tension you got 3 mg. Understood बच्चों?
Yes, sir.
Yes, sir.
So answer is B. Done. Like this, I have 19 problems for you. So we are going to solve a lot of questions and we are going to learn theory properly. So don't worry, stay tuned. There is probably one question you will get from the vertical circular motion. Okay, I'm sending you notes in the group. Whatever I have written and all these questions will come in the group. So please, all class 12th student will solve all 19 problems by your own. Okay. Promise you will solve all 19 questions and send me. Promise all class 12th student will solve all. Okay.
Yes, sir.
Okay. Now Neeraj sir is going to take class for the 12th student or 11th. I don't know timetable. It is for 12th. Am I right? Ajay ma'am. तो ये तो गया.
वो गया. ये लैपटॉप है, वो लैपटॉप है, ये कंप्यूटर उधर वाला कंप्यूटर है.
ठीक है.
और एक फोन.
इसकी जरूरत तो प्रोजेक्टर नहीं चाहिए किसी को अभी.
नहीं सर.
ओके, अभी मैं इसका क्या करूं?
आपने
लीव कर दूं?
नहीं तो आप इसको बना दीजिए. तो
वो वही है होस्ट तो.
नहीं,
कौन है होस्ट?
आप.
नहीं मैं नहीं हूँ, देखो.
मैं हूँ.
आवाज आ रही है सबको?
यस
चलो भाई स्टार्ट करते हैं आज। लेट अस स्टार्ट विद कॉमन टेंजेंट्स। रेस कर ली पूरी? डाउट है? एंड में डिस्कस करते हैं, ठीक है, क्लास के एंड में डिस्कस करते हैं। लेट अस स्टार्ट विद कॉमन टेंजेंट्स। तो कॉमन टेंजेंट क्या होता है सर? टेंजेंट जो कॉमन हो, एज सिंपल एज दैट। यस, सही बात है ध्रुव। टेंजेंट जो कॉमन हो वो कॉमन हो गई, कॉमन टेंजेंट हो गई, है ना? हाँ बिल्कुल सही बात है। फिलहाल के लिए हमारे लिए बिल्कुल सही बात है कि भैया कॉमन टेंजेंट का मतलब कि जो टेंजेंट दोनों कर्व्स को कॉमन हो, या दो भी जो फिगर दिए हो, जो कुछ भी आपको गिवन है उन पे कॉमन, ठीक है। ये उसको भी टेंजेंट है, वो उसको भी टेंजेंट है, ये मतलब हुआ, ठीक है। जैसे कॉमन फ्रेंड नहीं होता भाई, तुम्हारा भी फ्रेंड है, वो उसका भी फ्रेंड है, तो कॉमन फ्रेंड हो, वैसा ही कुछ। सो नाउ व्हाट वी विल डू इज वी विल सी कि भाई कॉमन टेंजेंट्स किस टाइप के होते हैं सर्कल में। तो सबसे पहली चीज तो आप ये देखो, वी हैव टू टाइप्स ऑफ टेंजेंट्स, DCT एंड TCT, ठीक है। दिस इज डायरेक्ट कॉमन टेंजेंट, डायरेक्ट